Hello. Um, yeah. I want to talk to you today a little bit about anonymous engineering and what it is. So, coming from 2013, surveillance has been going on, and there were encryption technologies emerging. And in 2013, James Comey, the FBI director, has given a speech on a thing called the going dark problem. And what he says is, unfortunately, the law hasn't kept pace with technology, and this disconnect has created a significant public safety problem. We call it going dark. So in the current paradigm of Web3, uh, we all use Ethereum, we all use Bitcoin and similar blockchains. They all have transparent ledgers. This is used to track wallets, to do analytics, to give you ads, to surveil you in a general sense. It's used to censor people, and it's used for law enforcement as well. What we have, what happened also recently, Tornado Cash, the developer was arrested, and the US enforced sanctions on such privacy tooling. In Dubai, we got a ban of privacy coins, of Monero and Zcash, and all like the layer two zero knowledge chains and similar things. Binance yesterday or 2 days ago also stopped and disallowed trading of privacy coins in France and also in some other countries as well. In the general sense, what we have in anonymity today, we have a view of these blockchains like Monero and Zcash. They take a different approach than the classic Ethereum type style transactions and account systems. They're more similar to Bitcoin, which uses like an UTXO set. They use techniques to enable privacy for people. So in Monero, we have ring signatures, we have bulletproofs, which allow us to hide the sender and the recipient, and we were able to hide the balances. It's not ideal, and Monero devs are also thinking about implementing ZK snarks to improve the anonymity set. Zcash uses zero-knowledge proofs from its inception, basically, and it's been working well. And some of their technology is also used in DarkFi. However, they didn't manage to scale to smart contracts because of technical debt. For example, Zcash was forked off of Bitcoin, I think in like 2015, and the problem there is like they had to build on top of these things. They didn't start from scratch. So they never managed to scale to have anonymous smart contracts or similar things. Monero was designed to be money, just as a currency, so I don't think they have any kind of plans to implement smart contracts. In Ethereum, we had attempts of gaining privacy and fighting surveillance through things like Tornado Cash, layer 2 mixers that, not only mixers, but anonymous pools where we can deposit money and then change it with other people's money as well, anonymously, and then we can withdraw this money to different addresses that are unlinked to the previous deposits. So we have a way on Ethereum to at least somehow anonymize our money. But I think it's only a stopgap because Ethereum, as on its base, is just purely a transparent chain. So wherever the money ends, you still know, like, yeah, it was transferred to this address, so like, let's follow. And you can, depending on the person's behavior, they might use their wallet in certain ways that de-anonymizes them. So I mentioned Tornado Cash. This led to US sanctions being put on the actual like smart contract front ends. It led to censorship in the sense that the websites that were not hosted on decentralized things were blocked from access, and arrests where we saw Alexei in Netherlands got arrested because of writing free software and working on Tornado Cash. So let's dive into a bit more technical things. I basically want to give you tooling and a general idea on what anonymous engineering is and how to actually build anonymous protocols. It's not like magical, let's put everything inside ZK and somehow it becomes anonymous. I also noticed people think like ZK EVMs and these types of things bring kinds of privacy. That's not really correct. They only use zero knowledge because of its succinct property. So don't assume that ZK EVMs or ZK layer 2s will bring you any anonymity in Ethereum. So what are ZK snarks? Let's say we have some secret values and I want to prove to them that I actually know them. So if I have secret data, I can hash it, but do it through a ZK circuit. So I will give you a proof along with it. This means that usually you can get a hash of some file or some data from the internet from someone, but then there is no proof that you actually own this data. But if I have this data and put it through some kind of caching circuit, I can give you a proof that I calculated the hash function from this actual data. So we take this assumption for our anonymous engineering, and we'll see how this works in practice. I want to talk also about sapling. It's a name of an anonymous scheme to use ZK snarks and homomorphic commitments like Peterson commitments to enable anonymous currency. This was designed initially by Zcash, but also we took it and expanded the concepts a little bit. So what it does, it consists of two phases. Phases called burning and minting. We have some object that exists as an output in the UTXO set. So this object can travel through the blockchain by being burned and then minted in a different place. So there is no link to each other. With these techniques, we can have currency on chain, but balances are hidden, and like payments from A to B, nobody except the parties doing it can see what's happening. But we use zero knowledge proofs to prove that actual state transitions are passed correctly. So let me see if this pointer works. Ah, yeah, cool. So we can say we have like a coin C, this object that I mentioned, and we use a zero knowledge proofs to calculate its values, its inputs inside. So let's assume there's a coin owned by Alice. So it's what it says Alice Pub, it's Alice's pub key. Then there is a unique serial number to each of these coins, and there's some value. So imagine it's like Alice's pub key is her address, and the serial is some random number, like you see on the cash bill, on the note. And the value is like 100, so that's 100 tokens. So in the first phase, when we want to send this money to someone, we will burn it and derive a nullifier. A nullifier is also, a nullifier is also hash of values, but in the nullifier we use this Alice's secret key and the same serial from the coin we have. So with this we actually prove that Alice indeed owns the coin. And then if we want to send it to Bob, we will create another proof of hashing Bob's pub key, which he gives us through some channel. We derive a new serial number and we reuse the value. And then we can reveal this C as a public input to the ZK snarks, so and check that it's unique. What this means that no two nullifiers can be the same, or no two coins can be the same. It has to keep changing. This does break chain surveillance. Maybe it's still a little bit abstract, but it does break chain surveillance because when we're burning a coin, we're just making inclusion proofs that it has existed, and the nullifier was not published before, so we cannot double spend. And then we're minting on a completely different coin, and they're unlinkable to each other because no addresses are public, no values are public. So we can extend this scheme to do more interesting things. For example, we can append another attribute called the token ID. So now we simply have ERC20 tokens, arbitrary tokens, on our network. We can extend it even more to add like the current slot ID. So with this, now we have a time lock mechanism as well, and we can use these techniques to actually like build cool systems, and on top of that, we can make smart contracts work in an anonymous paradigm. For example, one of the things we did in DarkFi is making the world's first anonymous DAO. So this is a mechanism to create DAOs. It's not a DAO on its own. It's a smart contract to create anonymous DAOs. So as I mentioned, we have the coin. That's something. We can also build a DAO the same way. So in a DAO, we have a proposal limit, which is like the minimum amount of governance tokens that's needed to make a proposal. We have some quorum that we want for a proposal to pass. We take note of what the governance token of the DAO is, and we also have a pub key of the DAO, which is essentially the DAO's treasury. So back here, when we have Alice's kind of public key, we can also have a DAO's treasury to be able to send money into the treasury. Then let's say we created our DAO, and then we can make a proposal. Somebody makes, I want to send money to WikiLeaks, so I'll make a proposal, and then we calculate zero knowledge proofs of hashing the WikiLeaks pub key, the DAO itself, so we can actually make note of on-chain. We can figure out which DAO is supposed to send it, and the amount that we want to send, and obviously some token. It could be any arbitrary token in the DAO's treasury. So we create a proposal, we publish it on chain. Now we get to voting. So I want to vote, I support WikiLeaks, I want this DAO to donate money to WikiLeaks. So we use homomorphic commitments to actually encrypt our votes. So we have our coin, our governance token, and we want to use it to vote on a proposal. So we will, when there is a proposal, we will copy the entire state of the Merkle tree, where all the coins are, all the existing governance tokens are as outputs in this tree. So we can prove that we have a certain amount of governance tokens, and we're allowed to vote on this specific proposal. And we can encrypt the yes and no using commitments. We can commit to them. And we can encrypt it with the DAO's key. So only the members of the DAO, and only after the proposal has ended, are able to decrypt the votes and see if the proposal has passed. So let's assume the proposal did indeed pass, and then we can execute the proposal. So this means we decrypt the votes, and if it passes the quorum, we will perform again the burn and mint scheme. So the DAO has its treasury, it has its coins. It's going to burn the tokens and mint them to WikiLeaks. What's happening on chain is somebody's token got burned, we don't know what it is, and somebody got some tokens. We don't know what they are or who they are. Anonymous engineering in DarkFi. Yeah, in DarkFi, we use these concepts to implement all these things as smart contracts. So everything on DarkFi is basically a smart contract. We use this to implement anonymous payments, atomic swaps between people, DAOs, as I mentioned, exchanges, anonymous NFTs, all these kinds of things. The goal of introducing people to these concepts is to remember that these schemes are supposed to be simple and modular, so you can build bricks with them, not complex. I think complex things are easy to do, and keeping things simple is the real challenge. So maybe I sparked some interest, maybe not, but if you do want to learn anonymous engineering or talk to us more, we do weekly seminars on math online. You join fully anonymously. You don't have to tell who you are, or you can join and ask questions, and we can study math and cryptography together. The DarkFi devs, we have a public meeting every Monday on our anonymous chat, which you can find easily. You can just search the internet for DarkFi, and it should be relatively simple. There's a threshold to entering, so if you can find that, you're welcome. And yeah, the DarkFi book is the MD book, where it's our wiki, and we hold very cool info, also philosophical and engineering, and how to study math, and also technical documentation about things. And I want to say DarkFi is just the beginning. As Bogdan had a nice keynote talk, we're still early, but we're expanding into a whole new paradigm of things. We're learning how to build anonymous systems. We're learning how to do anonymous engineering. We're learning how to break surveillance, and we're learning how to fight. So if you have any questions, I'll welcome them now. Thanks. No questions? Okay, there's a question.
In enterprise finance, there's a principle between confidentiality and privacy. Have you thought about confidentiality specifically?
Do you mean confidentiality?
Yeah.
Well, what do you mean by that?
So that if our regulator
Yeah.
wants to see the log of events or the
Yeah.
log of transfers, he would be able to do that.
They would, but the point is you would opt in. What's needed is privacy by default, and then if you want to show something about you, you should be the guy who chooses. I want to show you this data,
But
not be
not through
enforced by the state.
backdoors, right?
Sorry,
But not through backdoors.
not through backdoors, but you're in control of your data. You're in control of your money, so you choose when to reveal and to whom. Okay, cool. Well, thanks for listening, and enjoy the conference. Cool.